Hello all. The topic for the today's discussion is BCD adder. The BCD stands for binary coded decimal. So we know that BCD stands for binary coded decimal. Consider what is the operation that we are going to taken up for the study is consider two 4-bit numbers A and B, and which will be varying from your A0, A1, A2, A3, and the B number can be denoted as your B0, B1, B2, and B3. The value of A and B can vary from your 0 to 9 since it is an BCD adder. So 0, the binary value is your 0000, and for 9 it's your 1001 in binary, because we are considering the decimal values for addition. The output can vary from, okay, when you are adding two 4-bit numbers which is varying from your 0000 to 1001. See, consider, let me take the values of both the 4-bit numbers are your 1001 and 1001. When you add 9 and 9, the total value will be your 18. But whereas if the values are your 0000 and 0000, if your A and B are your 0 and 0 in decimal, then you can, when you add that, it will be your 0. Mid values, when you add, it can go up to from 0 to 18. If we are not, this is the condition when we don't consider any carry from the previous sum. But whereas if we consider a previous carry along with the sum, then what will happen is a single adder. Okay, so since you are having two inputs, each of 4 bits each, right? So this will contribute your 1001 and this will contribute your 1001, and apart from that, and when a carry bit is added, so 9 plus 9 plus 1, which is equal to your 19. But whereas when you don't consider the carry, it will become as your 9 plus 9, which is equal to 18 alone. When we add A and B, then we get the binary sum. Here, to get the output in BCD form, okay, when you add A and B, which is of BCD form, you will get the binary value. But whereas to get the output also in the BCD form, what type of protocol should be done, and what is the number to be added, and what is the sensitivities we have to take into account is dealt here. Consider we are having an input of A is given as 0101 and B is taken as your 1001. When you add both these, you will be getting this belongs to your value called as your 5, and this belongs to the value called as your 9. When 9 is added with your 5, it will give you 14. 14, when you give in binary, it will become as 1110. But whereas the output of the BCD adder is 10100. How you can schedule this is the first bit. This is the 4 bits, right? This 4 bit stands for your 4, and there is only single bit in the MSB, right? You append 3, okay, zeros in the front, so that will become as your 0001. The 0001 can be written as your 1. So 1 and 4. This stands for your 14. This is in the BCD form. But whereas when you add these numbers in a regular adder, A that is equal to 0101 and B that is equal to 1001, we will be getting task. Okay, we will be getting task your 14. So the binary of your 14 is your 1110. But whereas the BCD output is your 10100. This 0100 stands for your 4, and this 1 stands for your, you append pre-append triple zeros, means this 0001 is called as your 1. So 14 will be your answer. Explanation how we can take is, here we are adding A that is equal to 5 and B is equal to 9. The value of the binary sum is, okay, which is called as your 1110, which is your 14, but the binary sum will be your 10100. Here you take this 1 alone, and it can be written as 1 can be written as your 0001 in binary, and this 4 is called as your 4 is 0100 stands for your 4. So when this 1 and 4 joins, it is giving you 14. The routine and the protocol that we are doing is, say for example, the decimal number is varying from your 0 to 19. 0 to 19. Why you have took it from your 0 to 19 is, a single BCD number will varying from your 0 to 9. Okay, so 9 and as well as your another 9 along with one carry stands up to your 19. If you are not considering the carry, you can take only up to 18 itself. Okay, so the binary sum means when you are adding two numbers as your 9 and 9, when you are adding two numbers as 9 and 9, your binary sum actually will get when you add two BCD numbers of 9 and 9 with the help of two adders, your output will be a binary sum of your 10010. But whereas what the output you should get in terms of your BCD sum is your 11000. Okay, this should be the answer that you should get. See here, these 4 bits stands for your LSB and this 1 bit stands for your MSB. For this MSB, you can pre-append 3 zeros. So that means your 1000 stands for your 8 and your 0001 stands for your 1. So 1 and 8, 18 is resulted. So what type of notches that we have to take to convert the output driven binary sum into your BCD sum is, here you can see after 9 you have to, as of BCD is concerned, okay, when you are getting an output above 9 means, okay, when you are getting an output 9 above 9 means you should add a 6, okay, with the 9 value. Okay, so when you add a 6 with this 9 value, you will get it as, when you add a 6 with this 9 value, you will be getting it as your 10000. See here, in what are the cases you have to add a 6, okay, you have to add a 6. These conditions I have given here. See, from 10 to 19 you take it up, okay, from 10 to 19 you take it up. The binary sum is denoted as your C dash, this your carry bit, and your S3 dash MSB, S2 dash next MSB, S1 dash is your next to your LSB, and your S0 dash is your LSB as of your binary sum is concerned about. See here, you have to add 6 when your carry, okay, when your carry C dash is equal to 1, C dash is equal to 1, and next one is your B. Second condition is, here you see here from your 12 to 15, from your 12 to 15 you are having your S3 dash and as well as your S2 dash. S3 dash and S2 dash is there, right? That should be, okay, the multiplicand of that should be equal to, should be 1, and third condition is your S3 dash and as well as your S1 dash. Okay, these both should be equal to, the multiplicand should be your 1. So combinatorially, okay, all these three conditions should be taken into account. So that means the final expression will be C dash plus your S3 dash into your S2 dash plus your S3 dash into your S1 dash. Okay, these are the three combinations that we have to take. Whenever in this any one combination is 1, okay, any one combination raises the value as 1, then we have to add a 6 with the resulting value. So now let me go to the diagram. See here, this is a 4-bit adder. Okay, 4-bit adder means you can add two 4-bit numbers A and B. Here this 0 to 3 represents your A value, 0 to 3 represents, what you can do is your A0, A1, A2 and A3, and this B represents your B0, B1, B2 and B3. When you add two 4-bit numbers, your output will be your S0 dash, S1 dash, S2 dash and S3 dash. That is your binary output. You will be getting the binary output. Okay, means it implies that when your A is your 1001 and your B is your 1001, okay, then your output will be your, okay, your output will be 18. The binary output will be, okay, the binary output will be 10010 will get published. Okay, this one is your carry, okay, 0010 will get published. This is the binary sum that will get published when you add two 4-bit BCD numbers. But whereas what is the aim of this construction is, you have to get the output of this addition also in BCD. How that is possible is, you take, okay, now the expression that we have seen is your C dash. Okay, you take an OR gate, you take a OR gate, the C dash is added here, and then your S2 dash into your S3 dash. See here, your S2 dash into your S3 dash. That's what given here. S2 dash. Okay, you take it from your S2 dash and as well as your S3 dash. And next one is called as your S1 dash into your S3 dash. S1 dash into your S3 dash. Okay, you multiply both with your IC7408 and you give it to an OR gate. When that is taken, okay, that output is taken, and here another one 4-bit adder is there, another one 4-bit adder. When you get a binary sum, when that binary sum is added with, okay, when this binary sum is added with a value of 6, okay, provided this binary value should cross the value of 9. This binary sum should cross the value of 9, okay. So if that is the case, you will get one of these input will be, okay, one of this input will be equal to 1. If any one of the input is equal to 1, then you will be getting this value to be 1, and that value is given to the second and third bit here. So 0 1 1 0 stands for your 6. When this binary sum is added with the value of your 6, then your output here is called as your S0, S1, S2 and S3 there, right? This value is the binary coded output, and this value is also taken as your carry 2, okay. So the C, S3, S2, C, S3, S2, S1 and S0 is the binary sum. Hope you all have understood this session, okay. And one important thing is, when you add two BCD numbers, your output will be a binary sum only. If this binary sum is above 9, then if that is the case, you have to implement this function. This function is this carry bit and your S2 S3 dash and your S1 S3 dash, okay. C dash plus your S2 S3 dash plus your S1 S3 dash, okay. This should be added, and if any one of that is 1 means, then your OR output is equal to 1, and your second and third bit is given as connected to the output of the OR gate, so this will become as your 0 1 1 0. Now the binary sum when get added with your 0 1 1 0, your output will be your BCD sum. Thanks for listening, and have a good time.